Question number 1. Which of the following is a valid solution to the quadratic equation x squared plus 4x plus 2 equals 0? So I will solve this equation using the quadratic formula. So we're going to need to know what a, b, and c are. And of course we have ax squared plus bx plus c equals 0 for the quadratic formula. So in this case, a is 1. There's a hidden 1 multiplying the x squared. B is just 4. And c is 2. And of course the quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, now I can just plug these numbers into the quadratic formula. Just going to copy everything down first. Okay, all over 2a. Just going to put the numbers in a different color. So we have negative 4 plus or minus the square root of 4 squared minus 4ac all over 2a. Fantastic. Now let's just simplify. So we have negative 4. I can get rid of the parentheses. 4 squared is 16. Now, here we have 1 times 2, which is 2, times 4, 8. All over 2 times 1, which is 2. Now, we have negative 4 plus or minus the square root of 16 minus 8, which is 8, all over 2. Now we're almost done, but I want to simplify the square root of 8. And remember that 8 is equal to 2 to the power of 3. So if I have the square root of 8, that's equivalent to 2 times 2 times 2 inside the square root. So I can break this down as the square root of 2 times 2 times the square root of 2. 2 times 2 is 4, so the square root of 4 is just 2. I took the long way around to get to this. So the square root of 8 is 2 times the square root of 2. Fantastic. Now what? Negative 4 divided by 2 is negative 2. Then we have plus or minus. Now I can cancel these out once I split it up. 2 divided by 2 is 1. Multiplied by root 2. So we have two answers. Negative 2 plus or minus. That's what gives us the two answers. Square root of 2. So if we take a look here, C is the answer, because we have negative 2 plus the square root of 2 as one of the answers. And the other one, of course, would be negative 2 minus the square root of 2, but we don't see that here as an option. So we're done.